Hello everyone, in today's video we're going to cover section 10.6, more angle arc theorems. After studying this section, you'll be able to recognize congruent inscribed and tangent chord angles, determine the measure of an angle inscribed in a semicircle, and apply the relationship between the measures of a tangent-tangent angle and its minor arc. First, looking at congruent inscribed and tangent chord angle relationships. Now we can use our knowledge of the relationships between angles and their intercepted arcs to easily lead us to these next two theorems. First, Theorem 89, if two inscribed or tangent chord angles intercept the same arc, then they're congruent. So what this theorem is telling me is in my figure to the right, if I'm given that angle x and y are inscribed angles and they intercept arc AB, then they're going to be congruent. So I can see that angle X has endpoints AB, so it intercepts arc AB, as well as Y has endpoints AB, so again, it intercepts arc AB. So X and Y intercept the same exact arc, and the arc will always be the same measure. Inscribed angles or tangent chord angles are 1/2 the measure of the intercepted arc. If they're intercepting the same arc, then they're going to be congruent. In Theorem 90, if two inscribed or tangent chord angles intercept congruent arcs, then they're congruent. So what this theorem is telling me, in my figure to the right, if ED is the tangent at D and arc AB and CD are congruent, then we can say that angle P is congruent to angle CDE. Because angle P is an inscribed angle, so it's 1/2 the measure of the intercepted arc, where angle CDE is a tangent chord angle, again, 1/2 the measure of the intercepted arc. If the intercepted arcs are congruent, 1/2 of congruent angles is still going to be congruent angle measures. So angle P would be congruent to angle CDE. My next theorem deals with angles inscribed in semicircles. Theorem 91, an angle inscribed in a semicircle is a right angle. So my figure to the right, I have AB as a diameter because it goes through center O, and now I can conclude that C is a right angle, because if AB is a diameter, then arc AB would be 180 degrees. Angle C is an inscribed angle, so that's 1/2 the measure of the intercepted arc. It intercepts arc AB, which is 180. 1/2 of 180 is 90 degrees, and any angle measure of 90 degrees is a right angle. Therefore, C is a right angle. And lastly, we have a special theorem about tangent-tangent angles. So a tangent-tangent angle has a special relationship with its minor arc. Theorem 92 is the sum of the measures of a tangent-tangent angle and its minor arc is 180 degrees. Because, in my figure to the right, we have PT and PS are tangent to circle O, that means they're congruent. I also know that OT is congruent to OS, because these are radii. Now, OTPS is a quadrilateral. More specifically, it's a kite. But I know that angle S and angle T are right angles because radii drawn to the point of tangency creates right angles. Now, if S and T are both right angles, that means they add to 180. I know a whole quadrilateral is 360 degrees, so then angle O plus angle P would have to be 180 degrees. I know that arc TS would be the same exact measure as angle O because that's a central angle, and central angles have the same measure as their arcs. Therefore, the sum of the measures of a tangent-tangent angle and its minor arc is 180 degrees. Looking at an example of this, we have line PT and line PS are tangents at T and S. We want to find the measure of angle P. So you can see that arc TS is 130. I want to find angle P. I know based off my new theorem that tangent-tangent angles and their minor arcs add to 180 degrees. So I could just subtract 130 from 180 to get me angle P. So 180 minus 130 would get me an angle P of 50 degrees as its measure. Now, another way that I could think about this is I know that angle P is a vertex outside of the circle type of angle. Therefore, it's 1/2 the measure of the intercepted arcs. Well, I know that this intercepted arc here would be 360 minus 130, which is 230. So angle P could also be 230 minus 130 divided by 2. Well, 230 minus 130 is 100. 100 divided by 2 is 50. So that's another way to think about it. It's a lot easier just using my theorem, but we could use both ways. Now looking at our sample problem, problem 2, in circle O, BC is the diameter and the radius of the circle is 20.5 millimeters. Chord AC has a length of 40 millimeters. Find AB. So I want to find AB, so we'll call that X. I know that BC is a diameter with a radius of 20.5, so that tells me all of BC would be 41 millimeters. And then AC has a length of 40 millimeters. Now, angle A is an inscribed angle. It intercepts arc BC. BC is a diameter, therefore this whole arc is 180 degrees, making angle A a right angle. If angle A is a right angle, I can use Pythagorean theorem to find side AB. I know that this is a Pythagorean triple of 9, 40, 41, so AB is 9 millimeters long. In today's lesson, we learned if two inscribed or tangent chord angles intercept the same arc, then they're congruent. If two inscribed or tangent chord angles intercept congruent arcs, then they're congruent. An inscribed angle in a semicircle is a right angle, and the sum of the measures of a tangent-tangent angle and its minor arc is 180 degrees. That's a wrap on today's video. We'll see you in the next one.